Welcome to this guidance on human factors in SIRE 2.0 inspections. OCIMF has provided this guidance to support vessel owners and operators to help them understand what to expect from the human factors component of SIRE 2.0. It offers help on responding to human factor observations, as well as guidance on applying human factors to support your crew to be successful in their important work. Thanks for taking the time to watch this video. This is the briefing for vessel officers and builds on the all-crew briefing. If you haven't watched the all-crew briefing presentation, please watch that first. There are 4 sections in this guide. In the first section, we'll look more at performance-influencing factors, which we first met in the all-crew briefing presentation. In Section 2, we look at the inspection and how you can help the inspector get an accurate picture. In Section 3, we'll look at what the inspector will report, including some examples. We'll also look at why we avoid blame or naming individuals when reporting. Finally, in Section 4, we'll look at how to respond to human factor observations. We will talk about what we can learn from them and use the rule of thumb to get the most benefit from them. We'll also look at how you can get ahead of some of the issues inspectors may find. Now we'll look at more on performance-influencing factors. In the all-crew briefing, we saw how the way work is set up can cause people to fail or succeed. We called these things the performance-influencing factors, or PIFs, because they influence the performance of a person conducting the task. Let's look more closely at PIFs. The performance-influencing factors, or PIFs, are the physical, psychological, organizational, and social characteristics that affect human interaction with hardware, systems, processes, other individuals, and work teams. In SIRE 2.0, OCIMF has listed a set of PIFs that are most relevant to vessel operations. When inspectors are looking at a task, they are interested in these things which set people up to succeed or fail. They are looking for evidence that a task can be reliably executed in the future. Let's look at these PIFs in more detail. Group 1. Out of the thousands of tasks that need to be carried out on a vessel, it helps to recognize when a task is safety critical or when some small part of a procedure is really important to get right. It helps us design the task better, including making any allowance for preventing, detecting, and recovering from mistakes. Group 2 looks at the way people use procedures, whether people can get to them when they need them, and that they make sense and are helpful to people performing the task in real life. Group 3 considers the interactions in a team and between crew and leaders. People in fast-moving, dynamic situations rely on good communication, sharing information, and respectful challenge and response to maintain understanding of the situation and to take the right action. Problems are more likely when people are under pressure, overloaded, tired, unhappy or fearful, or trying to meet tight schedules. But more than anything, the mental health of the crew is a priority for us because we care for the welfare of mariners. Group 4. Sometimes it's the physical things which make work difficult. Physically awkward, uncomfortable or dangerous conditions can cause people to struggle to do what's expected. The interfaces and controls with machines and systems are an essential part of what people need to make decisions. Errors, misunderstandings, and silencing of nuisance alarms can occur when controls and interfaces are poorly optimized for people. A task can fail because people are asked to work beyond their normal range or with poor information. Finally, in Group 5, it's not enough to read or hear information. People need opportunities to be able to learn and practice in a variety of situations. A task can fail because people come across situations they are unprepared for or unfamiliar with. We might think that a good set of procedures are enough to ensure a safe operation, but procedures can cause difficulties too. Sometimes there are too many procedures, they are too detailed, or they will conflict with each other. Sometimes they'll be inaccurate or maybe stuck away on a computer in the supervisor's office, and no one can get to them when they actually need them on the job. They might not be helpful or understandable. Importantly, there might not be a process that says, okay, out of all the tasks that have to be done, there are some procedures or individual steps that are critical, and require a higher level of control, oversight, or cross-checking. All of these things can lead to procedures not being trusted, not being used, or simply not very effective when they are used. But even when procedures are well designed, the task is always going to be different to the procedure. How can that be? One thing to remember is that real life is dynamic and complex, and we rely on crews adapting to make things work. Let's talk about a concept called work as imagined versus work as done. Work as imagined is how we thought things would go when we sat down and developed a plan or procedure or designed some hardware. Work as imagined is represented by the black line that runs down the middle of this chart. Work as done is represented by the blue line. This is how the job is actually done, in real conditions, and relies on tips and know-how. It's like navigating a ship. The black line might be the course line for a planned passage. The work as done, or the blue line, is the actual course made good with all the influences of traffic and weather. We expect a difference. In real work, the blue line moves along, sometimes being better than the plan, sometimes worse. In fact, there are all sorts of pressures which people deal with and adapt to try and keep the task broadly on plan, some of which are listed below this line. This sort of adaptability is what we rely on people for, and normally it goes okay because there is a margin of safe operation where we can afford some flexibility. It's shown here as the green band. But that margin isn't obvious, and it's difficult to judge when we are in the middle of a task. On occasion, the task varies too far from what was imagined, or the safety margin is too narrow. It's only then that the organization really notices what's happening, because some unwanted event or incident happens. Think about a task where you had to know a tip or a trick to make it work. One mariner told us about a situation where he was a new recruit on a vessel, being shown around by master. The master took them to a control panel and showed them where a red button and a green button had been wired up incorrectly. The master told the new recruit that he had to remember that green meant stop and red meant start on that panel only. People will often make the best of what they are given and adapt to make a task work. Inspections are interested in work as done, so are looking at how tasks are really carried out, even when there is a procedure for them. We can imagine that our performance influencing factors, or PIFs, are on a control panel. Until we look for PIFs, we don't know how successful the task is likely to be. When we have healthy PIFs, shown here in green, tasks are likely to be reliable because we are supporting people to be successful with the right conditions. When some PIFs are unhealthy, shown here in red, tasks become more difficult and errors will creep in, or people will need to adapt the task to make it work. When a lot of PIFs are unhealthy, there is a strong likelihood that the task will fail. However, the good news is that we can address unhealthy PIFs and increase the likelihood of a successful task.